Hello smart learners, today you will learn about basics of C++ part 2 with the help of examples. So these are the outline of this video, which goes up to 3 slides, which goes up to type conversion. Let's explore this one by one. So what are integer variables? Variables are most fundamental part of any language. The variable has a symbolic name and can be given a variety of values. Variables are located in particular places in the computer's memory. When a variable is given a value, that value is actually placed in the memory space assigned to the variable. Most popular languages use the same general variable types such as integers, floating point numbers, and characters, so you are probably already familiar with ideas behind them. Let's define integer variable. Integer variable exists in several sizes, but the most commonly used is type int. The amount of memory occupied by the integer types is system dependent. On a 32-bit system such as Windows, an int occupies 4 bytes, which is 32 bits of memory. While type int occupies 4 bytes on current Windows computers, it occupied only 2 bytes in MS-DOS and earlier versions of the Windows. Examine the output window. The statement int var1, int var2 define two integer variables var1 and var2. The keyword int signals the type of variable. These statements, which are called declarations, must terminate with a semicolon like other program statements. You must declare a variable before using it. However, you can place variable declarations anywhere in the program. It's not necessary to declare variables before the first executable statement. However, it's probably more readable if commonly used variables are located at the beginning of the program. Identifiers. The names given to variables and other program features are called identifiers. What are rules for writing identifiers? You can use upper and lower letters and the digits from 1 to 9. You can also use the underscore. The first character must be a letter or underscore. Important information is that identifiers can be as long as you like, but most compilers will only recognize the first few hundred characters. You can't use a C++ keyword as a variable name. A keyword is a predefined word with a special meaning. For example, int, class, if, and while are example of keywords. Assignment statements. These statements assign value to the two variables. The equal sign, as you might guess, causes the value on the right to be assigned to the variable on the left. Now we'll discuss integer constants. The number 20 is an integer constant. Constants do not change during the course of the program. An integer constant consists of numerical digits. There must be no decimal point in an integer constant, and it must lie within the range of integers. Moving forward to next topic, which is handle manipulator. The last stay-out statement in the int vars program ends with an unfamiliar word named as handle. This causes a line feed to be inserted into the stream so that subsequent text is displayed on the next line. It has the same effect as \n character, but it is somewhat clearer. It's an example of manipulator. Manipulators are instructions on the output stream that modify the output in various ways. Now discussing other integer types. There are several numerical integer types beside type int. The two most common types are long and short. We noted that the size of type int is system dependent. In contrast, types long and short have fixed sizes no matter what system is used. The type long always occupies 4 bytes, which is same as type int on 32-bit Windows system. In 16-bit system, type int has the same range as the type short. Moving forward to next topic, which is character variables. Type character stores integers that ranges in value from -128 to 127. Variables of this type occupies only 1 byte, which is 8 bits of the memory. Character variables are sometimes used to store numbers that confines themselves to this limited range. Much more commonly used to store ASCII characters. Moving forward to next topic, which is character constants. Character constants use single quotation marks around a character, like single quotation marks A and single quotation marks B. The C++ compiler encounters such character constants, it translates it into corresponding ASCII code. And it occupies only 1 byte in the memory. Now let's discuss escape sequences. Since the backslash, the single quotation mark, and the double quotation mark all have specialized meaning when used in constants, they must be represented by escape sequences when we want to display them as characters. Floating point types. We've talked about type int and type char, both of which represents numbers as integers, that is, numbers without a fractional part. Now let's examine a different way of storing numbers as a floating point variables. Floating point variables represents number with a decimal place, like this, and this. They have both an integer part to the left of the decimal point and a fractional part to the right. Floating point variables represent what mathematicians call real number, which are used for measurable quantities such as distance, area, and temperature. Let's examine it with the help of a program which prompts a user to type in floating point number represents the radius of a circle. It then calculates and displays the circle's area. Okay, this is the variable of type float, and this is type constant float, and this is the prompt that is given to user to enter the radius of a circle. And here we are getting a radius, here we are finding area, and here we are displaying the answer. Okay, this is the area in square feet of a 12-inch LP record, which has the radius of 0.5 feet. At one time, this was an important quantity for manufacturers of vinyl. Moving forward to next topic, which is type double and long double. The larger floating point types, a double and long double, are similar to float except that they require more memory space and provide a wider range of values and more precision. Okay, what is type bool? For completeness, we should mention type bool here, although it won't be important until we discuss relational operators in our upcoming videos. We've seen that variable of type int can have billions of possible values, and those of type character can have 256. Variable of type bool can have only 2 possible values, such as true and false. In theory, a bool type requires only 1 bit, not a byte of storage, but in practice, compilers often store them as bytes because a byte can be quickly accessed, while an individual bit must be extracted from a byte, which requires additional time. Unsigned data types. By eliminating the sign of the character and integer types, you can change their range to start at 0 and include only positive numbers. This is the table that is given below, shows the numerical range of unsigned integer types. Also, the bytes of memory that is going to be used by these keywords is given in this table. Moving forward to next topic, which is castes. Caste sounds like something to do with social classes, but in C++ the term applies to data conversion specified by the programmer as opposed to something which is called automatic data conversions. Castes are also called typecasts. What are castes for? Sometimes the programmer needs to convert a value from one type to another in a situation where the compiler will not do it automatically or without complaining. There are several kinds of castes in standard C++. For example, static caste, dynamic caste, and reinterpret caste, and constant caste. Here we'll concerned only with the static caste. We'll learn about the others in our upcoming videos. Okay, here is an example of casting. Here the variable to be cast, and int var, is placed in parentheses, and the type it's to be changed to char is placed in angle brackets. The result is that an int var is changed to type char before it's assigned to a char var. In this case, the assignment statement would have carried out the cast itself, but there are situations where the cast is essential. Okay, why do we use the cast? Cast should only be used when absolutely necessary. There is a controlled way of evading type safety, which means making sure that variables don't change types by mistake and can lead to trouble because they make it impossible for the compiler to spot potential problems. However, sometimes casts cannot be avoided. We'll see some of the example in our upcoming videos. Till then, we are moving to our next topic, which is arithmetic operators. As you have probably gathered by this time, C++ uses the 4 normal arithmetic operators such as plus, minus, static, which is known for multiplication, and division, / for division. These operators work on all the data types, both integers and floating points. Moving forward to next thing, which is remainder operator. There is a 5th arithmetic operator that works only with integer variables types char, short, and int and long. It's called the remainder operator, or you can also call this modulus operator, which is represented by a person sign, which finds the remainder when one number is divided by another. Okay, moving forward to next thing, which is arithmetic assignment operators. C++ offers several ways to shorten and clarify your code. One of these is arithmetic assignment operator. This operator helps to give C++ listing their distinctive appearance. The following kind of statement is common in most languages, this one, and we can also write it like this. Moving forward to our next topic, which is increment operator. Here's an even more specialized operator. You often need to add 1 to the value of an existing variable. You can do this the normal way, which is count is equal to count plus 1, which adds 1 to the count, or you can use an arithmetic assignment operator, which is count plus equal to 1, which adds 1 to the count. But there is an even more condensed approach, which is plus count semicolon. The plus operator increments add 1 to its argument. Now let's discuss prefix and postfix. As if this were not weird enough, the increment operator can be used in 2 ways: as prefix, meaning that the operator precedes the variable, and as a postfix, meaning the operator follows the variable. What's the difference? Often a variable is incremented within the statement that performs some other operation on it. For example, total weight is equal to average weight, static plus count semicolon. The question here is this: is the multiplication performed before or after count is incremented? In this case, count is incremented first. How do we know that? Because prefix notation is used. Plus count. If we had used postfix notation, for example count plus, the multiplication would have been performed first, then count would have been incremented. Now let's discuss decrement operator. The decrement operator minus behaves very much like the increment operator, except that it subtracts 1 from its operand. It too can be used in both prefix and postfix forms. Okay, we are done with now our variable topic, data type topic in C++. This was all from my side. Thank you so much for watching the video.